In Chapter 14, we will study the managerial decision-making under uncertainty. When we consider problems with uncertainty, we need to use the theory of probabilities. So I will first review the basic concepts in probability theory. Probability is a number between 0 and 1 that indicates the likelihood that a particular outcome will occur for an event. And for these events we are considering, we say the outcomes for these events are uncertain. That means there are multiple possible outcomes for this event. In other words, when we say that for an event, the outcomes can be uncertain, we mean that the eventually realized states of nature can be several different situations. In this picture, the event we are considering is the days of rain per month. And for this dry city, there are several possible outcomes. Either there's no rain in a month, or there can be 1 day of rain per month, or 2 days of rain per month, 3 days of rain per month, or 4 days of rain per month. Each bar here shows the probability. So for a given month, there are 40% of chance that there are 2 days of rain in that month. When we put all these probabilities and the different outcomes together in a chart, it's called a histogram. And this kind of picture shows the probability distribution. That means we relate the probability of occurrence of each outcomes to each possible outcomes. If we compare panel A and panel B, we can see that the outcomes in panel B are more concentrated around the middle of the probability distribution, while in panel A it's more scattered. So we say there's a little bit less uncertainty in this probability distribution in panel B than in panel A. For panel A, because the outcomes are more scattered from the middle of the distribution or scattered away from one another, we say the probability distribution in panel A has less certainty in it. In general, we can say this probability distribution contains more risk than the probability distribution in panel B. Now let's think about where we can get these probability distributions. One way to get a probability distribution is from the historical data. So let's say we have 100 years of data for the rainy days in this very dry city. And there are 1200 months in these 100 years. So we can count. For months, there are no days that it rains. There are 120 months. And for the months, there are only 1 day that it rains. There are 240 months. 2 days of rain in a month, there are 480 of them. 3 days, 240 of them. A month that it rains for 4 days, there are 120 of them. So these numbers are our historical data. And what we do is that we use this 120, divide it by this 1200, and then we get 10%. For the months there's only 1 day it rains, we use this 240 divided by 1200, and we get 20%. And so on and so forth. So we get the so-called frequency of months that contain a certain number of rainy days. And from these frequencies, basically we can call these frequencies empirical probabilities. So we can use these frequencies as probabilities and to calculate the so-called expected value. Sometimes it's called expectation. And it's a basic way for probability theory to express the idea of average or mean. And what we do is that we use the probability here to weight the value of the outcomes. So we use this 10% times 0. we get 0. This is the probability weighted value. It's 0 of the outcome. There's no range in a month. And then here we have this probability of 20. Use this 20 times 1. Again, this is the value of the outcome. This one says that there's 1 day it rains in a month. Here we have 40% times 2. Probability weighted this value 2 for that outcome. And for each value, we use the probability to times it. Then we sum everything up. We get the so-called expected value, EV, as in the textbook. This expected value of 2 tells us the average number of days that it rains in a month. So if we consider another month in this very dry city, we can say, more or less there will be 2 days that it rains. By the way, I'm using Excel here to demonstrate the calculation, and I hope that this calculation process can help you to understand how do we get the numbers for the expected value, variance, and the standard deviation. Hopefully you have learned these concepts before in other courses, but if you haven't, this is a review, and perhaps you will need to read the textbook more carefully if you have never thought about random events and probability concepts. In Excel, there is actually a more convenient way to calculate the expected value. That means we can use the sum product function. Here, we just put these two array of numbers. One is the values of the different outcomes, and the other is the probabilities for those outcomes to occur, and the sum product function can give us the expected value here. It's the same number that we had before. And then I just carried this calculated result over this cell to facilitate my later calculation of the so-called variance. The concept of variance measures the spread of probability distributions. So basically, again, we go back to the idea of how scattered the possible outcomes are around the mean. So here we actually have the average or the expected value listed. And then we take the difference between the values of possible outcomes and the expected value. So 0 minus 2 is negative 2. And here, the expected value is 2, and this outcome is 2 as well. So we use 2 minus 2, we get 0. For this value of outcome, there are 4 days that it rains in a month. We have 4 as the value of that particular outcome, and 4 minus 2 is 2. So this column basically measures how far away each value for the possible outcome from the mean, from the average of all possible outcomes. Because the mean is in the middle, if we sum these differences up, more or less we'll get 0. We cannot effectively summarize the scatterness of this distribution with 0. So what we have to do is to square them up. We need to make all these distances sum up as a positive number. So we take the square of them, then each distance become a positive number. And finally, we do the same thing that we have done when we calculate the expected value. We use probability, it's 10% here, to weight this squared distance. And same story here. Use 20% to weight how far this one is from the expected value. And we squared that distance. So it's the green cell weighted by this blue cell. Again, for each squared distance, we use the probability to weight it, and then we sum the numbers up, we got the so-called variance. This is just a sum function, sum all this 0.4, 0.2, 0, 0.2, 0.4 up to 1.2. That is the variance. This variance concept help us to have an idea about how scattered the probability distribution of the outcomes for this event are. Basically, in standard theory of decision-making under uncertainty, the variance shows us how much risk there is in an event. And this variance number is actually in different units for the values of the outcomes. From this example, it is hard to see that because 1.2 is quite close to 1, 2, 3, 4. But let me put some different numbers into the values. To make my example more obvious, I use an extreme number. I put 25 days of rain in a month. Maybe just there's a rainy season there, and the probability for that to occur is 10%. Now we have this different set of values for the outcome. Then we can look at this variance calculated. It's 49 something. That is much bigger than the 1, 2, 3 and the 25. Also, we notice that the expected value is only 4.1, and this 49.29 is more than 10 times of this expected value. So because we are taking the squares for the distances to make them sum up as a positive number, the calculated variance is actually in different unit than the expected value. And what we have to do is to square it back. We take the square root of the variance so that we get this concept so-called standard deviation, which is just the square root of the variance. And this standard deviation has the same unit as the expected value and all the values for the possible outcomes. So this standard deviation gives us a better idea about how much the values of possible outcomes scattered around the expected value. And that's the basic probability concepts we need for making decisions under uncertainty.